Okay, in the last video, we successfully got to a point where our car was able to control its motors according to what the code on the Arduino said. And theoretically, we could then program in any kind of complicated routine and have the car drive around in that pattern. But one of the problems is that the relays act in a very digital type of fashion where they are either totally closed or totally open, which means the car is going at full speed every time that we tell the motors to turn on. It'd be nice if we had a way to get some of the slower speeds in between, ends up giving us more control. We're going to be able to do that with a real common type of transistor that we use with motors. It's the TIP 120 NPN type Darlington power transistor. And like a lot of transistors, it has 3 legs, and we'll learn a little bit about what these mean. This will act as a throttle essentially for our car. Before just looking at this in the car, which is already kind of complicated, I think it'll be helpful if we look at this with a simpler system to understand how they work the way that they do. First of all, let's return to our picture that we drew of what the relays are accomplishing on the car. If you remember, it looks something like this. We had our positive voltage from the battery coming in, putting it through 2 different single pin double throw switches that connected to the motor on either side. Allowed us to route that electricity from the battery so that it would go either left or right. We're going to add our transistor component before the electricity can reach ground. So literally we're going to like strangle how much current can flow through here, literally throttle it. And the more we throttle it, the slower the motor will turn because the less current flows through it. So the schematic symbol for a transistor is a little bit more complicated, but this is a kind of simplified summary of it. There we see the 3 legs. Charge is coming in on one of the legs, so we call that the collector, or C. It's coming out and going to ground here on the emitter leg, or E. And there's a 3rd leg which controls how much current can flow from C to E, from the collector to the emitter. We call that the base pin. And you might have guessed it, that base pin is going to connect to our Arduino, the Uno, or any other microcontroller you're using that has an analog output. But before we connect it to the Arduino, we want to protect our Arduino from any big current that might be able to reach it. So we add a resistor in there. Something around 1,000 kilo ohms would be good, maybe 2.2 thousand ohms, still appropriate. On the Arduino, we need to connect to a analog pin if we want to get fine control over how much that throttle is actually working. If we just used a digital pin, we'd basically be able to open and close the transistor, but we're able to accomplish that already with our relays. By having an analog pin, we can kind of slightly open the transistor, let a little current through, and get all those different shades of speed that we really want to achieve. One last thing, schematic-wise, that we're going to need to add here, which is a little confusing to understand at first, but the emitter leg is connecting to the ground of the battery pack on the car. We're going to need to take another wire that's connected to that and take it over to the Arduino as well, and connect it to a ground on the Arduino. That's so essentially the power that makes the Arduino work, which is coming from the USB cable right now, is agreeing with the battery pack over here on the car what we mean when we say ground. What is 0 volts? If we're both standing up at a height and I'm only 3 feet off the ground and you're 20 feet off the ground, and I tell you to come down 3 feet, and then you're going to be able to safely jump without hurting yourself. That's only true for me and not true for you. You're still going to fall 17 feet. So that's kind of the importance of agreeing where is the ground, right? And that's what this wire does there. Okay, so we're going to practice this with not the car, like I said, but a separate motor here just so we can see things a little bit easier. So this is a motor that's even beefier than what's in the RC car, and it's connected to this gearbox. So it takes quite a bit of power to make this run. To power this, I've got a benchtop power supply, which I just turned on, connected here with some jumper wires to this breadboard. So if I put this thing up at like 12 volts, that should be enough to make this thing work correctly at its kind of regulated speed. I've got a jumper wire from the power supply into each of the power buses out here. So one of these is at 12 volts, one is at ground for the power supply. I can just complete my circuit with the motor here, and it'll start to spin, which is difficult to see for you, so I'll put a little post-it note on there. Okay, so that should be a pretty simple circuit there. We've just got charge coming in, goes through the battery, comes out, goes to ground. Now, if I want to control that speed, something that is slower than this, we're going to need to include our transistor. So on the breadboard, I'm going to take my TIP120 transistor, and with the 3 legs, plug it into any 3 rows on my breadboard. The 3 legs had the names of base, collector, and emitter, and that is the base to the farthest left, collector is in the middle, and emitter is on the right. And that kind of changes from transistor to transistor, so you always want to kind of look it up online just to make sure you're right. And that would be wrong if I put this in backwards. So when I'm talking about the front of the transistor, it's the one where you can actually see TIP120 printed on the front. The one wire of the motor, right, is connected to the positive power supply. But before it goes straight back to the negative, we're going to put it into the collector of the transistor, which was the middle leg. Then we're going to take our emitter coming out here, that's the right leg of the transistor, and take that back to ground. Nothing happens, right? Because the transistor is closed. So charge is coming in on the red wire, goes through the motor, comes out, hits the transistor, which it can't get through yet, and then would theoretically finish its route getting back to ground that way. We need our base to have some voltage on it between 0 and 5 in order to open this. So that's where the Arduino is going to come in. But remember, we want to protect our Arduino. So I've got a 1000 ohm resistor here. It's got its 2 legs. One leg's going to go into the row with the base leg, furthest left leg of the transistor. And the other leg of the resistor I just threw into any open row. I put it out to the left there. Here's a free Arduino that we can use to look at this, one that's not already tied up in the car. I'm going to connect that resistor leg to any of these analog pins that I have. So on the Uno, any of these analog pins you could use because we can put a value between 0 and 5 volts. Or you can use these digital pins that have a tilde in front of them. That's the little wavy sign. That tilde doesn't mean that they're truly analog pins, but they can do a trick called pulse wave modulation, where they turn on and off really quick to kind of mimic a voltage that's somewhere between 0 and 5 volts. I'll actually use one of those. I'll go with pin 3 because pin 3 has a tilde in front of it. One last wire that we need to include was that ground wire, so that when this gets powered and we know what ground is here, it's agreeing with what the ground of the power supply going through the motor is. There's 3 grounds on the Arduino. I can choose any of them, and that's going to go to the emitter pin of the transistor. I could also put it just straight into the ground going back to the power supply because they're the same, right? So there's just a jumper wire connecting those already. I'll go with the emitter pin because it's a little bit closer. All right, so when we power on the Arduino right now, still nothing's going to happen. because we haven't written any code for what this should do. So let me switch over to all right, back over here to the computer where we can write some code. I've just opened up a new Arduino file, and we are gonna do just some real simple stuff here, so it doesn't need to be too fancy. The setup function, we're gonna need to do a pin mode to define that pin that we're using to control the transistor with. So remember, we use pin 3 because that was one of the ones that is pulse wave modulated, or can make it, pretend that it's a analog pin. And we're going to use it as an output. We're going to be sending electricity out on it. In the void loop, our main goal is to have this kind of step up through a couple of speeds over time and then maybe drop back down again. So to do that, we're going to use a new function that we haven't used yet for the robot called analog write. It's very similar to digital write. Digital write could write a pin to 0 volts or 5 volts, high or low. Analog write will allow us to do any value between 0 and 5 volts. Much like digital write, it takes 2 inputs. The first is what pin it's writing to, and the second one is the value that we want it to write to. And here we're actually going to enter a number instead of just high or low. We can use any number between 0, which is 0 volts, or 255, which would give us 5 volts. That might seem like a random scale, 0 to 255, but in computer science, that's kind of a special number. If you include 0 in that list, that's actually 256 possible combinations. And it might not jump out at you right away, but 256 is 2 raised to the 8th power, or 2 times 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 2. That gives you 256. What's special about that number is that's the total possible combinations of ones and zeros you can have if you have 8 placeholders of ones and zeros in a row. So a single placeholder of a 1 and 0 is a bit, and if you have 8 of them, we call that a byte. So basically, this is like 1 byte of information with a scale of 0 to 256. You may need to look that number up again, later to remind yourself, but you can just Google analog write online and you'll find that. What we're going to start with is analog writing that to 0. So if I just uploaded this code right now, the motor would still never run. Now we're going to increase it by about 20%. We'll go up to like 50, but I want a little space in between each of these so we can see what's going on. So let's add a delay of a second before we increase the speed again. All right, and the next part here, I said we're going to go up by 50, so I'll just copy and paste this part of the code and make that 50. That's about 20% of the range. I'm going to take this all the way up to 255 and then drop it back down to 0. It's pretty repetitive, so I'll just speed through this part of the video. All right, so just to review the work that we've got here, we set the pin mode in the setup once. The loop function, which will happen over and over again, we'll put 0 on the transistor, which makes the motor do nothing for 1 second. And then after that, it's going to slowly increase by increments of 50 each second until we reach the maximum value here, and then drop down by increments of 50 until we get to the bottom, and it goes back to the top of the loop again and repeats that. So we should see the motor speed up and slow down a whole bunch. Let's go ahead and connect our Arduino to the computer and upload this code. It's a new Arduino, so I better connect the COM port. And here we see our code. Slowing down to a stop and slowly increasing 20% every second. Great. So it seems to be working as expected. And that's the basics of how the transistor works. One thing that I'll point out here as a common mistake is forgetting that common ground between the Arduino and the power supply for the motor. Just so you can see what happens if you don't have that. It can be helpful for troubleshooting. Okay, so if this ground is unplugged, basically nothing happens. Usually nothing happens. And that's because even though this transistor is trying to increase and decrease its open amount, it's not agreeing with the range of these voltages. I can hear the motor is just buzzing a little bit, so there must be a tiny trickle of current getting through, but not enough if we don't have this ground connected. All right, so hopefully with this cleaner talk through and example, it'll make more sense when we put this into the robot in a second, because we're going to need to disconnect a few wires in our power supply here on the relay board in order to put that throttle in between. So stay tuned for that in the next video.